DeFeo, your host today. We'll give a couple more minutes for people to sign in. We've got quite a few folks from around the world today. I'd like to remind you that you can send a question or comment through the on-screen chat. Unfortunately, you're not going to be able to talk to me, but I can talk to you. And so please send me your comments, your questions. Even just say, hello, I'm here. It helps me think that there's actually somebody out there, which I know there are. We are now embarking in the future of quality. Juran Institute and our training partner, Impro, have been here for about 40 years, providing various training, consulting, advisory, certification. And today's webinar is about what we know so far about Quality 4.0 and building a plan to go from here to there. And it's very difficult to know where you are and where you're headed. I did take a look at each of you and where you come from. So there's a range of companies from small to very large, from manufacturing to non-manufacturing and healthcare. And so I hope you could take a little bit about what we talk about and bring it home wherever you might be. Since this is a new topic and a very fast moving topic, I'm going to do my best to kind of shed light on what we've learned so far and what you can do to kind of build a plan. This live webinar was really put in place because so many people we speak to that are either quality professionals, operational professionals, are asking and being challenged with transitioning their current quality management system to a technology-driven Quality 4.0 management system. And today we're going to talk about what that means and try to present a startup plan to get there, wherever there may be. We've got three kind of points I want to make here today. The first is, what is a smarter quality management system? We hear about digital 4.0, but I think if we talk about making our quality management system smarter than it is today, being digitally or technology driven, you can kind of start to advance your thinking if you're a beginner. If you're an intermediate person thinking about this, it may be a good way to talk about what quality management is going to become. Secondly, what impact it will have on you as a professional. These changes are causing each of us to undergo and learn a new language and some new skills. And then talk about the plan and building how and when. So I hope that's why you're here. And for those of you who've just come into play here, please send along any questions or comments that you might have via the chat box. At the end of this presentation, we'll let you know how you can receive a copy or a link to our discussion here today. So let's go. I'm also using a new presentation system. I hope you like it. It's a little bit more upscale and higher tech than the traditional PowerPoints. And I might be a little bit confused about it, but I hope you enjoy it. So the first question we have is, why digital quality? Why are we even talking about that? And simply put, to keep up with our fast-paced customers and market, we need to rethink how we manage for quality. Quality is a support system to the organization. It could be seen as a support system. It could be seen as the conscience of the customer. But nonetheless, we have to be in the business of providing support to our own organization to ensure that they meet the customer requirements. And in order to do that, we not only have to be good at that, we have to be efficient at that. And one reason that digital quality is so enticing is because it does improve efficiency. Now, I mentioned the word smart and smarter quality system when I introduced this session. Here's a quote from a very good, and experienced pharmaceutical chief quality officer. She said, quality management systems must be smart quality systems. We need to move from paper-driven, time-consuming tasks to digital, data-driven, faster completion of tasks. So if you think about where you are and where you want to go, you want to move from reactive to predictive. We want to move from paper to no paper. We want to move from time-consuming tasks waiting for data to instantaneous data wherever you are. And if you're new to this, start thinking, where in my process can we make connections to get away from anything to do with manual operations, manual paper, and start moving towards this smarter quality system. Now, no one dreamed of a smarter quality system per se. It's been a evolution and revolution that's going on now in a lot of our factories around the world. And the smart factory has becoming smart because we have been integrating and getting all these different manufacturing systems collaborating with each other in real time to meet supply chain demands and the process capabilities in the factories, the whole supply network and customer needs in general. If you think about a factory of interconnected machines and people and data and supply chains and customers, no longer is it a static environment, it's quite a dynamic environment. And that dynamic environment, moving towards more sensor technology to be able to capture real-time information from the operation, is enabling the operation to be more efficient and more effective. That's putting pressure on support services like quality management to become more effective and more efficient. So one of the biggest driver of quality 4.0 is the smart factories. And those smart factories are forcing us to be smarter quality management system. What does that mean? Well, if we look at the tasks that we are responsible for in a quality management system, clearly there's inspection, and inspection is done sometimes by the quality function, other times by people who make the product. The closer inspection is to where doing the work, the better. But nonetheless, there are requirements for inspection. Some are regulatory requirements, some are customer requirements. And those inspections are taking place at a time when we need faster, quicker supply chains. So any inspection is going to slow down the process, or if the product is producing while we're testing and inspecting, we're just creating more good or bad product in the event that something goes wrong. So inspection can be minimized and even eliminated if you believe that all the variables that create good product are controlled at a level that is so good that it doesn't create any defects. And some of the technology that is out there today, particularly in sensor and machine capability technology, it is doing just that. We have machine maintenance. No longer do you have to wait for a piece of equipment to break or equipment to go down. The information that is being sent and monitored in the smart factory tells it when it needs to be adjusted, tells it when it needs to be maintained. So the speed at which machinery can be maintained and the avoidance of a catastrophic failure can occur, it is part of the smarter technology, and therefore it requires us to change. How we perform audits, and audits are nothing more than less frequent inspections. We perform audits by asking for information about either a supplier or one of our own operations quality systems, what we have in place for checks and balances, and we ask those questions, we do a walk around, and we get confidence that whatever is in the review or the audit is meeting requirements. Well, if you're doing 10,000 of those a year and you're traveling around the world to do them, this past year really made you think about how better to conduct an audit. And so audits themselves maybe become and already becoming a virtual audit. The next step behind a virtual audit, which means you can see the person you're talking to, is the interconnectivity of your customer data, your supply data, and your own data. And so where we used to send product to and from a supplier to a customer, and that certificate of quality that went with it, well, no longer will the certificate have to go with it. The data transmission of the data can go directly to the customer or supplier or wherever it has to go. Sampling. We sample based on the quality and the process capability that we have. If we have low process capability or have a very difficult process to maintain, we sample more. The more predictable and reliable that gets, we sample less. So sampling is going to become more important, but also possibly less and less, faster and faster, because we should be controlling more than we are controlling today. Even rapid improvement events or quality improvement or continuous improvement is going to be part of this smarter system. Why? Because a lot of that is root cause corrective action. And root cause corrective action is about collecting information about the current status of a process or problem and analyzing what's going wrong with it. And then analysis is of data. And through artificial intelligence and smart algorithms, we can continuously monitor the data, looking for trends to avoid failures. But in the event of a failure, we can do a rapid improvement event by having that same AI take a look at the data that is existing prior to the defect and try to find the cause and move much quicker. Throughout all of these, you notice a picture, it's documentation. Documentation to either educate, like in the work instruction, or help people do their job, to documentation where we have to provide information to regulatory agency or to customers, documentation to be able to record tasks and activities and test results that are done. Whatever it is, documentation is also a major contributor to this. And over the last 10 to 20 years, quality management systems have gotten smarter as it relates to documentation. There are many organizations providing documentation management systems and quality management systems based on that, such as Viva or Intellex. These are large quality management system documentation-like management systems. And if you are one of the companies that are already engaged in implementation of some of these systems, you know that each new system you implement takes a bit of time to get through it. Manufacturing for years was implementing ERP systems such as SAP. And just when you get it in place, there's an evolution or revolution or new packaging that goes with it. So once we move towards more digital technology, we can assume we're going to continuously improve on that and continuously increase our, I guess, our scope of our quality management system. Now, one of the tougher areas to plan for is what I call smarter quality control. And here we have a basic process in blue, and it's a series of steps sequenced to each other, and it creates an output. And in yellow, there are work instructions and people who carry out those steps. And then there are the checks, the critical to quality characteristics with a decision symbol to determine pass, fail, go, no go, within spec or out of spec. And historically, the gray critical to quality control checks lag behind the operational process steps. We collect data that takes too long to get. We have to run tests, put them into a lab, and then make a decision. Each one of those take time, each one of those slow down the process, and each one of them can make or break the process. Well, smarter QC is really dependent on the capability of the sensor technology that's available for your given manufacturing or service process. So for instance, if you're in the Let's say that you are in a application business where you have a mortgage application, or people have to fill out forms. You may have a technology that allows you to fill those forms out online, but when you print them, there may be differences in them. Well, there's optical technology that can detect those differences. Well, if you don't have the technology, you don't have that real-time data. Sensor technology in manufacturing operations have existed for years, but it's evolving and moving much quicker. So where you have a physical sensor, like a thermostat, a digital thermostat, or a scale, uh, or a colorimeter, they used to produce data, which the data would be transferred into a computer. Now that data is being analyzed automatically in a computer. And that next level of technology is to actually control the piece of equipment the data is coming from. I consider quality control to be the critical but laggard in the process of moving to a smarter quality management system, mainly because manufacturing has sensors that have to be adapted, as well as in service industries where there's really not much sensor going on. So you have to ask yourself, where's all that data coming from? So smarter QC may lag behind various aspects of quality management, like documentation management or corrective action. Now, what exactly will a smarter quality management system entail? Well, right off the bat, there's data quality and the ability to analyze, to collect, analyze, and act on data. So if we are sending all of our data today to a mainframe or a cloud-based computer system, is that data available to anyone who wants it at any time in the way they want it? The answers are probably no. So we have to plan for how are we going to connect all our databases. Then we have that data. How do we share it? Is it in the cloud? Is it easy to get at? Can we control it? And obviously the speed is going to have a big factor in our plan. Reducing things speed up things, so less inspection, less test, less control, less root cause analysis will drive speed, which, by the way, the more speed we go, the faster we go, and the faster we go, the faster we want to go. So it's a self-fulfilling prophecy. The impact on cost of poor quality, I should say the impact on cost of quality. It's not just on the cost of poor quality, but what are the investments we're making and need to make in quality planning, quality of design, quality of prevention techniques, and our ability to predict when something goes wrong. So cost of quality will become as important as cost of poor quality. In other words, what we spend and where we spend it is going to be very important. And then the last one are the skills that are needed and the skills that are going to change that will make us smarter. So if we want to be smarter, we have to do more with data, data quality, information sharing, speed, cost of quality, and of course, enhance our skills. Now, if we can break down digital 4.0, I use the word sensors, but really there's a lot of intelligent machines and intelligent equipment that is being connected to each other through whether they be manufacturing applications or some large scale computer system. The connectivity of those intelligent machines is giving visibility that we once had independent of each other and separated from each other, all in one place that we can use and share. The ability of advanced analytics and be able to not only use algorithms to analyze data, which are numbers, but also using AI technologies to even see visible changes in something that the human eye can't see. These advanced analytics are providing a much more accurate way to see defects, particularly. Working with a large glass manufacturer, they used to sit in a room, and as a sheet of glass moves down the assembly line, light would shine through it, and you'd have to look at these massive 4 or 5 meter sheets of glass for defects. Well, today there's an optical sensor that monitors that and gives you a picture of where those defects are. The next level of using that same technology is to send a signal back to the beginning of the line to adjust something if we're getting more or less defects. The third part is people at work. When you start connecting people, the people don't have to be in the building anymore. And so we have people working from various places, getting data wherever they are, when they want it. But the design of that and the control and maintenance of that have to be of a higher quality, because now we're susceptible to people stealing data or people giving up that data when they should not be. And lastly, we'll probably see more standards for quality based on the ability of our systems to be protected. And we could think about this the way the United States has carried out the implementation of health records in our healthcare system. We had many health records, but as soon as you start giving access to those health records, you create opportunities for people to hack into those records. So I envision, and we envision, there'll be more quality standards for how do we design, control, and continuously improve digital processes in the future. So what does this impact on you? And those of you who are participating today, I'm going to refer to you as quality professionals. And although we may not act professional sometimes, we use that in the sense that we have the responsibility to manage quality within our organization. And that could be at the product quality level or at the enterprise level or anywhere in between. But with these new digital technologies, we have to plan for our own change. We're going to have new questions. There's going to be new ways to test and unknown unknowns. Quality engineers might find themselves in positions where they have to explain things they're never seen before, and quality managers the like. So what is it that might be new? Well, we may have to explain how new tests and systems are working. We may have to communicate constantly to management about what is changing and why we need more money to facilitate the digitalization. Justifying the use or acquisition of these new systems to the procurement people. Articulating increasingly complex work to many stakeholders. If we're connecting to suppliers and we're connecting to customers, and if we think about the change we could have, the complexity in itself is mind-boggling, and therefore the number of stakeholders will increase. We have to still continue to be advocates on behalf of the customers, where organizations might think about doing quality 4.0 because it's more efficient. We actually want to do quality 4.0 because we will be able to provide better quality products and services. You might have to mediate between stakeholders. The ability to have the knowledge and the ability to share that knowledge may be seen differently. And there's a whole bunch of personal relationships, even competitive relationships. For instance, we've seen the operational engineers, operations and operators in manufacturing take the lead on the implementation of smart factories. And they may be putting in place technology that minimizes the importance and need of quality management. Well, you have to be capable of helping them understand what stays and what goes, what changes and what doesn't. And so you may have to defend yourself. And also you may even have to challenge yourself to make those necessary changes. So what skills do we have to think about for the future? Well, the continuation of systems thinking. We can't think of little q, we have to think of big Q, bigger than ever. The interconnectivity of our systems, the data-driven decision making, and how we're just beginning to use data that is, I would consider to be on a low maturity level to really use in huge databases faster, and we don't have that much experience with it. You're going to have to take the lead on organizational learning when it comes to digital quality. And if you think about some of the people that work for you or some of the people you have to help learn, they may not be digitally oriented. You're going to have to establish continuous improvement on the digital system itself. You're going to have to understand how decisions affect people. So more critical thinking skills are important. And then interpreting bigger data sets. We were laughing the other day. You know, the quality control chart for process control requires 25 data points to get a true picture of what it's saying. And 250, 500 data points, but how about 100,000 or a million or a billion? What does that tell you and how fast do you get it? Its effect on sample sizes, its effect on interpretation is going to be huge. And so you're seeing the need in companies to hire big data specialists and big data analysts, when in fact, we may have them right in our own company. We just have to stretch our learning a bit to make sure that we understand how we can control processes with such large data sets. So how do we fit all this and do something different and plan for it? Well, the first question at the bottom is, where are you and where do you want to go? So here you are in 2021, and I have heard from numerous companies, some that are just trying to understand what is quality 4.0, others that have begun the implementation by implementing the larger scale document management systems, root cause corrective action system, analysis tools, or they're in line to begin the implementation as they are implementing new technologies in their organization that will soon impact them. And others are at a pretty advanced state using quite a bit of AI and sensor technology and benefiting from that, even to the point of reducing cost of poor quality to almost zero in some applications. So depending on where you are, you're either going to be manual, partially digital, you're going to be fast or slow or cumbersome. And so you've got to know where you are and take a look at the future. Where do you think you want to be based on where the technology is going? So the future, which is fully automated, interconnected business systems with quality systems, maybe 5 years, 6 years, or even 10 years down the road. But my feeling and my lesson learned is you can't dwell on what that future might be. You just have to start moving in the direction of smarter. And it's an easy way, I believe, to get your arms around it. So if you think of what you're doing this year is you're baselining what you currently have, and then think about next year, targeting those areas that you believe have the biggest, best impact and ability to transform. One of the reasons why many organizations choose to go after the documentation management system is because the control of documents is so critical, because documents that are out of control could be leading to defects or deficiency or harm or whatever. And it also is a massive undertaking that once it's done, we can easily update and maintain those documents. Another area where organizations and quality are finding the benefits are in improved root cause analysis, root cause corrective action, 8D-like processes, where corrective action from customers or customer complaints are coming in, they're able to be monitored, and so on. And so depository for documents and information that can enable us to do a good job seems to be a good starting point. The hard part, as I mentioned, is the automated process control in a given factory. That's where additional technology is coming in. And then 2022 and beyond that, expand based on affordability. And then obviously in the future. Now I realize that this is not a great timeline, but I guess my point here is don't try to think about the future when it comes to digital technology so much today. You got to think like a lean startup. What can we do now? What can we do to become smarter? And if somebody wants to throw a lot of money at us, then we could do something different. But you're in lockstep with operations. And so you have to show yourselves as a service to operations and at the same time a service to your customers. And so what I'd like to do is get you to think about a plan. Now, the American Society for Quality, in conjunction with Boston Consulting Group, did a study on basically the relative importance and maturity of digital quality systems in organizations. And one of their outputs was a roadmap. And although it's a good roadmap, it's at a very high level in the sense that it just talks about identifying opportunities and develop a roadmap to go after it in quick wins and then scale, kind of like what I just described. But if you'd like more information about that study, you can go to the ASQ in the United States website or go to BCG's. There's some pretty good information in there. And I cite this because it's one of the few documented research studies done right now that provide some useful information. We like to think of building the plan as a startup plan. And with a startup plan, you just have to look in the near future, not the far future. So let's think about where you are and decide. Identify the areas that can help move us to a smarter system, but help our business now. For instance, if you're in manufacturing and your corrective action process takes so long, find a way to improve the technology of that corrective action system so that you can fix that and support your operation. Versus spending an endless amount of money trying to document the cost of poor quality and digitizing that. That may benefit you later, but not now. So identify the areas that can move forward, but help the business now. So most organizations think about documentation management, corrective action, and then lead up to control planning and managing the critical to quality characteristics and the work instructions, etc. Now, it doesn't stop you from thinking about your dream destination, but the technologies are changing so fast. We may have a dream destination, and when we get there, the technology changes. So I know this doesn't sound like a very intelligent statement, but technology changes so fast that the most you can think about is the near future. And so your dream destination may be interconnectivity, but you may not know what it will be interconnected by. And I also then say to socialize your decisions. What does that mean? It means sharing, collaborating, discussing what you're trying to do without necessarily making it a point of we are going to do it. In other words, socializing means we talk about it, get more information, and then move forward. And as you do that, you can begin your preparation. And the preparation is somewhat of educational, get educated on some of the tools, the technologies. And let me give you an example. We are working with a partner out of Hong Kong called FireVisor. They have an incredible tool, an algorithm in that tool that can search data and find patterns and trends that would have taken a black belt, an expert, statistician hours, days, and weeks to find without ever leaving their office. And learning about that technology isn't learning about what is the algorithm, it's learning that there's a tool out there that can look at our data and tell us something we don't know faster than we can do it. So education comes in learning some of the technologies and the tools available. Another one is what's called manufacturing apps or manufacturing applications. A company in Boston called Tulip specializes in manufacturing applications, where they create a hardware device that allows you to connect a sensor to it and then the output to a cloud, and therefore that cloud can come down to a screen so you can get real-time pictures of data. Another tool used. So provide education on the tools to the people that are going to need them most, and begin to provide education on the changes that would take place as a result of those tools. We believe you need quality management system implementation must be multifunctional, that this cannot be done in a vacuum without operations, mainly because you're servicing operations, particularly if you're in manufacturing. And that multifunctional steering team would be quality, maintenance, operations, engineering, facilities management, might be on that team together to be able to understand what each other is doing for that smart factory so you can link into that. We like you to think of selecting new technology similar to the project by project concept that we promote. And most Lean Six Sigma programs do that. Each technology or each part of the quality management system should be a project. That project should come clear with a problem statement, a goal statement, and an ability to implement a new change that leads you in the right direction. And so if you think about 100 different things you have to do to become interconnected, prioritizing them and launching them project by project will probably save you a lot of time in the end. And that same steering team will manage those projects. So what we see is just like in a transformation of a company, or using our trained experts like Lean Six Sigma, green belts and black belts, putting them together in a program like this with a problem statement that says we want to convert A to B, we'll be able to do that. And then once again, communicate and socialize what you prepare. Launching and expanding is basically, you're going to launch the new technology that you came up with in your prioritization. And we stress the importance of making sure that's aligned with your regulatory requirements, whether you're doing ISO 9001 or whether you're doing automotive or pharmaceutical, anything to do with regulatory. You want to make sure that you are embedding in your digital process the requirements of that. One of the great things about digital technology is the evidence and proof that you're doing what you say you're doing. And a lot of the documentation required from regulatory agencies want proof. And so digitizing things gives you proof a lot easier. Unfortunately, it also gives you a picture of what you're doing wrong. So aligning with your regulatory agencies is important. And of course, monitor progress, continue skills training. And if anybody could spot the typo on this page and send me a note, I'll send you a gift. Expansion, which might be 2 or 3 years out, is move on to more difficult tasks, such as real-time process control, and focus them on your more pressing critical to quality characteristics, and then continue to move through the plan. When you get to a sustain mode, you're probably going to be acting different, thinking different, and there's probably a whole different set of skills in your quality function. And if you're not straight with yourselves and not straight with your people, digitizing manual labor eliminates manual labor. And that labor, let's say you're doing inspection, either you're going to retool them, retrain them to do something else, or you're going to end up with less labor and people are going to be concerned about their jobs. So you can't lose sight that these technologies are going to decrease labor hours, and those labor hours may be tied to people's jobs. And so as you think about the technology implementation, you should also think about these 5 phases as it relates to the human resource. And if we're going to act differently in the end, we have to decide how we are going to deal with the excess labor component as we prepare and launch. Now, I know a lot of you are saying, wow, this isn't much of a plan, but what we wanted to get out there is what we know today. There's not a lot of experience, although there's moving very quickly. We've participated in a number of implementations of pieces of Digital Quality 4.0, and we could tell you these components we've told you, but something new is coming up every day. Also, it depends on your industry and the technology that you have today versus tomorrow. And so I hope that you got some benefit from this discussion. And if you'd like more information on this subject, we do have other papers on our website. And if you are looking for any further training, either this webinar or another one like it, or more detailed on truly process control implementation in real time, we have training, advisory, and certification through Juran Institute. And I'd like you to keep in touch. You could do that by chatting with us on our website. That little annoying box will pop up and you can ask a question. You can reach out to our staff at juran.com, or you can reach out to me directly. We hope that you do that, and we hope that you will come back in a month or so and follow up on the next one. What I'd like to also offer you is that we will be sending you a link to this presentation if you want others to see it. This is a new technology, so it doesn't have slides per se. But if there's a graphic that you thought you'd like or you want more of, please send me a note directly, and I will make sure that you get that. And I have a few minutes here for questions. And I know that some of you have questions because they've been posed to me. So I'd like to give you a second or two. And maybe I can ask you a question. Is anyone out there listening feel that they are in an advanced mode of digital quality 4.0? Say yes. Is anyone out there just beginning their transformation? Say yes. And the rest of you are somewhere in the middle. So, with that pause, waiting for the responses, I'm going to guess that you, based on the companies that I looked at and the attendance of today, which is quite a few folks, you're all scattered from beginning. Some are lost, some are really advanced, some are confused, some are dumbfounded. Whatever the expression is about your company, I would really love to have a poll and ask you how you're doing, what you're doing, and what you could use help in. So if you feel comfortable, send me an email, drop me a line. I really look forward to hearing from you. If there are no further questions, here we go. We got one question. You mentioned the company Tulip and the manufacturing application. Can you explain a little bit more about it? Well, if we think about a manufacturing process like the one that we had way in the beginning of all the steps that we took, and recall. I'm going to go to it now. If we think of these manufacturing steps, and each step provides output of data, but that each sequence cannot see that data. And we were to put a TV screen in between each one of these and show that data as the data is moving along, we would get visibility of how the process is performing. The manufacturing applications allow you, the user, to design what you want to see on that screen coming from that database. You might decide to look at just output data. You might look at 2 critical points in between. You might want to look at the decision making here. So the manufacturing application is a link between the process step and the data coming from it to a screen or something that you can see and act on. And so Tulip is one of the many that are out there. They just happen to be one I'm familiar with and we've seen in operation. They came out of MIT, Massachusetts Institute of Technology, and they're new technology, and they're doing very bang up job of creating these manufacturing applications for you in a way that's affordable and with even quality engineering experience, quality manager experience, you can work to create applications that may benefit you. And I hope that answers that question. There are many Tulip companies, so make sure you put in Tulip, Cambridge, Massachusetts. FireVisor was the other one, another company that does, I guess would be data mining, and they are based in Hong Kong, soon to be in the US. And it's coming upon 2:50, and so I am going to say thank you, and I hope that you guys all come back again in the near future and follow up with me if you have any questions. So thank you very much and good day.